Hi guys, welcome back. Today we're going to be going over a method called compressDuplicates. And in this method we're going to take a stack of integers as a parameter and we're going to replace each sequence of duplicates with a pair of values. A count of the number of duplicates followed by the duplicate number itself. Now, for example, say that we have this this stack of 2, 2, 2, 2, 2, minus 5, 3, 3, 3, blah, 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 yada, yada, moving on forward. So what we see here is we see that we have 5 individual 2's, so we want to take that number into consideration, and we want to print that 5 in the stack. And then after that, we want the 2 to follow. Now, we go to the minus 5, there are 2 minus 5, so it's a 2 followed by minus 5. 4 3's, so we follow up with a 4 and then a 3, so forth, so forth. And we can see that it's kind of intuitive based off of what we've seen. The new stack indicates that the original occurrence is, 5. That's what we kind of went over. So we're dealing with the important parts here. If the stack is empty, our method should not change the stack. So we should never change the stack if it's always going to be empty. We can use a queue to solve this problem, which is fine because we are actually given these helpful methods called s to q and q to s. Now, for those of you who don't know what on time is, it basically means we do not want to nest any loops within each other. Because if we get a loop that runs through, then we say, okay, that's O of n times. If we nest a loop with inside a loop, we say that's O(n) squared. And if we end up saying we nest 3 loops within a loop, then we end up getting something like O(n) to the 4th power, which the runtime of O(n) to the 4 would make our program really slow. In some cases, it would, if we were dealing with a very large kind of list, or a stack, it would take eons to solve it in some cases, or maybe, just a year. Anyhow, let's move on. So, we know that we want to create this new method called compressDuplicates. Now, is it going to be returning anything? Well, the answer to that is going to be no, it's not going to return anything whatsoever, so we're going to start off with a public static void. And we're going to call, well, because we've already been given the name, it's going to be called compressDuplicates, and from the spec, it says that it's going to be taking in a stack of integers, and we're just going to call that s because we're fairly lazy. And anyways, let's move on. So what do we actually want to do here? Well, if you noticed from our little spec here, it said we are allowed to use a queue somewhere here. We are allowed to use one queue as an auxiliary storage. So we are allowed one data structure for this problem. So first things first, queues make it a lot easier to deal with stacks because with stacks you can only look at the top part, remove the top part, to progress through the whole thing. But with a queue, we can kind of loop through it, look at the first element, pop it off, put it to the back, so forth. So the way we're going to do this is we're going to declare a new queue called queue of type integer. Name it queue. Keep missing the queue there. And in this case, we cannot say new queue of integer. We have to declare it by calling new linked list of the type integer. Now, there are a couple ways you could go about this. You could just immediately start popping things from the queue to the stack and start dealing with the elements in the queue at that point. But remember that when we put elements in a stack into a queue, we reverse the order of the elements. And that's not how we want to deal with this program here. So if you noticed, we do have access to the following 2 methods. S to Q, which is basically putting the stack into a queue, and then Q to S, which is re-putting the elements in the queue back into the stack. Now, these, of course, flip the order of things. So what we want to do in this case is we know that when we put things into the queue from the stack, it's going to be upside down, so we're going to call this. S dot is empty. That's the instance method there for those of you who didn't catch that. Q dot add S dot pop. What this will do is this will add the top element of the stack each time to the queue, and what will happen here is it will say, okay, so the list is not empty, the stack is not empty, so I'm going to add the top element of the stack to the queue. And what happens when I call this s.pop, it removes the top element from the stack so it no longer exists within the stack. And this keeps continuing up until the stack is empty, so eventually we get a queue that is, oops, whoa. We get, oh, something's wrong. Oh, that's why, I'm in plain text. We get a queue that stores the elements of the stack in reverse order. Let's actually put this all into here. Yeah, there we go. And what we want to do is we want to put the elements back. We want the elements in the queue to be in the same order that they were in the stack. So once again, we're going to call upon our method here is empty. But remember, we can replace this thing right here. We do have a method for this, and the method actually ends up being s2q. And it's going to take two parameters. It's going to take a stack, and then it's going to take a queue. And we've already declared queue. So we're actually going to call that instead of just doing these redundant while loops. Now, of course, in this case, the stack is empty, so we actually need to call upon queue to stack. And then we need to run through that again so that we can get everything in the order that we want. It's going to take a stack, and then it's going to take a queue, and actually this needs to be flipped, so that's a stack, it's a queue to stack. So when we reach this point, we know that the elements in the queue are in the order that we want. So what do we do at this point? Well, what we could say is let's look at the queue. So if the queue is not empty, now in this case the queue actually is not empty because we know that we just filled up the queue with elements. What we're going to do is we're going to declare a variable called last of integer. Why? Because we're dealing with a stack and queue of integers, and we're going to basically remove the front of the queue itself, and we're going to say that's the last thing we've looked at. Now, we want a counter here, and the reason we want a counter is because we want to keep track of the number of occurrences of a particular element. So we set that counter to 1. Why 1 and why not 0? Because when we pull something from the top, we know that there's one case of it. If we decided to put the count before, what we would end up having is int count equals 0, and then we'd set this to count equals 1, but that's completely redundant code. You don't need that whatsoever. You can just simplify it with this. So now that we've declared these two variables, we want to loop through the queue here so that we can actually start testing things to the last thing we looked at. So we're going to say while the queue is not empty, we want to run through it because we have something, and we're going to say the next element that we're looking at is going to be q.remove. Because what happens is the first element is removed, and it's stored in this temporary reference called last. And same sort of spiel here. This will take the first element off, this will take the second element off, and what we want to do at this point is we want to start testing the equivalency of next and last. Because, we want to get how many consecutive occurrences of the certain element exist within the stack itself. So we're going to say, okay, so if next is equivalent to last, then we know that we want to increase the count by plus plus, which basically means our count goes from 1 to 2. We now know that we have 2 copies. So at that point, we know that we do not need to change the value of last, because what will end up happening is we'll completely remove next, and then we'll move on to the next element once we iterate back through the while loop. And so in our else case, what ends up happening here? Well, at this point, we know that last is not equivalent to next, so we actually need to reset last. Last needs to change to a new element. There's no point in comparing an element that we already know is not kind of, not met any matches here. So we need to reset last, but we also need to push things to the stack. Now, how are we going to actually push things in the stack? What do we push to the stack first? Well, if you guys remember from our spec here, we noticed that we have 5 instances of 2, and we push 5 to the bottom of the stack, and then that's followed by the number that we were looking at. So what we actually want to say is we want to say s.push count. We want that to go to the bottom of the stack. Then after that, we want to push the value, and our value just so happened to be last, because last is the thing that we're looking at. Next is the thing that we're comparing it to. Now, so we know that we need to change last, but we need to change last after we do this, because if we say we change last to equal to next and progress further, then what ends up happening is we lose track of the 2 that we were we lose track of the first number that we were originally comparing, and we end up storing the second number with the wrong number of occurrences. So we actually need to take this code down and add it to the very end here, so that we reset that value there, and we progress further and look at the elements, the next element. And then we want to reset the count to be equivalent to 1. Why do we reset count? Because we know at this point we're no longer progressing the count. We're no longer incrementing the count, and we're dealing with a new number to look at, and we want the count to be reset to 1, because this declaration outside of the while loop does not affect anything. It does not redeclare itself within the while loop. So after we get the while loop casing done here, what do we want to do? Well, at this point, we know that we've already looped through the entirety of the stack itself. So what do we really want to do at this point? Well, this happens while the stack is not empty. But if you guys notice, the integer next stores this value here. And notice that we never push s next to the stack. We changed last to next, but we're never storing next. So what we end up needing to do is we need to put that last element back in. And we know, because we do have one last element stored in next, we do know that count is equivalent to 1, but because we're outside of the while loop, we know that count is initialized to 1 automatically, so we want to push that count onto the stack, and then we want to push the last element onto the stack. Oh, I said that wrong, didn't I? Yeah, I did. I really said that wrong. We actually want to end up pushing the last element of the stack onto the stack because the next element would not exist at that point. What would end up happening is, yeah, because next is storing this value and last becomes next, last becomes next, next stores this value, meaning last stores this value. We get out of the while loop because nothing exists, because the queue is empty, but we still have a lingering value, so we want to push that lingering value back in. So we say s.push and last. And this ends up being the solution to the problem. And we'll see you guys in the next video. Holy moly.